Hello, I'm Angelo Rodriguez, and today I will be doing a quick presentation on the computer networking field. So, what is computer networking? Computer networking refers to the connected computing devices that communicate within a network. So, literally any two digital objects that communicate with each other is technically a network. So, it could mean something as large as a big lab full of computers, printers in a corporation, or something as small as like maybe two smartphones sending a file to each other directly towards each other, meaning only two devices are involved in that network. That is considered a computer network. Computing devices and Internet of Things. Computing devices were traditionally defined as computers, laptops, and industrial logic controllers that manage machinery. However, with the rise of microprocessors, many things have become computerized. The Internet of Things is the networked interconnection of objects of diverse nature, such as electronic devices, sensors, but also physical objects and beings, as well as virtual data and environments. And this definition is from a book by Gajkowski. So why talk about the Internet of Things? As our civilization advances, we become more technical and more advanced, and more devices are becoming computerized. Things such as TVs, cameras, doorbells, or even refrigerators and light bulbs. These are all devices that are becoming computerized and give you a greater degree of control over how you use those items and also utility. And the more devices you put out on the network, the more resources it uses up. And when you add devices into the network, you're scaling it up and you're going to need more management. You're going to need more IP addresses. You're going to need more routing capabilities within your networks. And also it increases your surface of attack, so you're going to need to make sure all of those devices are properly secured with things like IP addressing and proper security protocols. So what is a network technician? A network technician is a person who is responsible for the implementation, maintenance, troubleshooting, and upgrading of computer and networking systems within a organization, or maybe a house, anywhere really that has a computer network, which could be lots of places: airports, schools, universities, stores, small businesses, large businesses. And on this part, I will start talking about the networking implementation, starting with the copper twisted pair, fiber optics, etc. So the copper twisted pair and fiber optics are the medium that the data is used to be traversed throughout the network. For example, the cable. So you can have copper cable or fiber optic cable, which is like rays of lights that travel at ultra fast speeds, and also even wireless Wi-Fi is being transmitted through the air using radio waves. Servers, switches, and routers. These are the devices that are used to facilitate networking, and the servers are the devices that implement certain protocols, like you could have an email server or a administrative server, which takes care of all the tasking done for like users and accounts and all that kind of thing. And switches are the devices that are what connect all of the other devices together. So basically, if you went to college and you went and plugged your laptop into the wall port, or a LAN drop as many people like to call it, you're not actually plugging your computer to the internet. What it really is you put your cable to the LAN drop, and the drop goes through a network of most likely copper twisted pair cables, and it takes you to the switch, and the switch identifies your computer and it knows exactly where to direct it if your computer were to need to go to the internet. And the router is like a gateway between networks. So for example, you can't just have one big network for a large university. What's most likely the case is there will be separate networks between either departments or buildings, like geographic locations and things like that. So it's probably going to be something more similar, like you have a library network, then you have a math building network, science building network, medical building network, so on and so forth. And the router is like it's like the border patrol kind of for those networks that allow things in and out. And if you want something to come in or out of the network, it has to go through the router first. Routing protocols such as OSPF, EIGRP, and RIP. I'm not going to go into too much detail on what each of those routing protocols are, but for the sake of this presentation, a routing protocol is like the logic that the switching and the routers all use in order to redirect your traffic in the most efficient manner possible. They use certain metrics like cost, bandwidth, duplex speeds, hop count, possibly. And they all use a lot of complicated formulas and algorithms to try to calculate the most efficient or fastest path possible, or even the most reliable path, and that's how it routes your information to get from point A to point B. And IP addressing and subnetting. What is an IP address? IP, which stands for Internet Protocol Address, is a unique logical address given to a device that allows it to communicate with others. Think of it as like a house address. So each computer in the network has an address, and if one computer wants to talk to another computer, the most likely destination it will use is the IP address for that computer. There are mainly two types of IP addresses, that being public and private IP addresses. There are certain designated ranges that are private IP addresses. And just an example of a private IP address would be like 192.168.0.1. That's a Class C private address. You could tell because of the first three octets, 192.168.0. These three octets are all reserved for private IP addresses, so if you were to make a network in your home, you type in those three octets for your IP addresses, and the last one could be any number for whatever device you want it to be. And another one is 25.36.221.67. That's just a random number I came up with off the top of my head, but I know it's not in the range of a private IP address, so this is definitely a public IP address. So what is subnetting? A range of IP addresses that represent a piece of a network. IP addresses are made of binary bits, zeros and ones. And in each IP address there are 4 octets, and each octet consists of 8 bits. Let's take a look at the IP address 192.168.0.1. So if you take a look here at the octet I wrote down for each number, you've got here 192, which is this octet right here, and you see there are 8 possible spots for numbers down here. They can only be 1 or 0 for binary. And the first number down here represents 128. Second one is 64. Next one is 32, 16, 8, 4, 2, and 1. So for the number 192, you have the first 2 bits down here with a 1, which is 128 plus 64, which gives you 192. And then this octet down here, if you add 128 and 32 and 8, you get 168. And the third octet is all 0, is a decimal 0, so you can automatically assume all of the binary bits are 0. The last one is 1, so obviously the last one, which stands for a 1, is going to be on, which is a 1. Next address you have here is 192.168.0.173, and this is the binary for that address. Following the same rules here, same thing applies. This octet for this one, this octet for this one, and so on. And if you wanted to subnet this address with a 25-bit subnet mask, that means the first 25 bits are reserved for a network address. So if you were to count all these ones and zeros, the 25th number would be right here, right after the 0 right here in the 4th and last octet. So the network address is borrowing 1 bit from the last octet, meaning that the address is 192.168.0.0 and 192.168.0.128, since that 1 is the 128 and the bit that's being borrowed. Those two addresses are network addresses. So anything between 1 and 127 is the first network, and anything between 129 and 255 are the second network. So you're splitting a class C address, which has up to 252 hosts, into half. So there's only 126 on one network and 126 on the other, but it's only borrowing a bit from the last octet. So that's one way you could segment one large class C address with all the bits in an octet, and take 1 bit away and be able to split that into 2 networks. So those 2 devices if there were 2 devices and one on one network and one on the other, you try to talk to the other network, you can't do that because they're part of a different network because of that 1 borrowed bit from the subnet mask. So you would need a router to be able to communicate between the 2. So now on to the networking troubleshooting. So what kind of issues might a network technician run into on a day-to-day basis? There are lots of issues ranging from things like low bandwidth, which is like really slow download speeds, or choppy internet, choppy calls to the internet, intermittent or no connectivity, which means your internet just isn't working or sporadically works, and applications not working correctly, like you can't send a mail or you can't make a voice call for whatever reason. I gave an example for the presentation, and the CEO recently got a new computer installed in her office, and now she does not have network connectivity. What happened? The technician attempts to ping the CEO's computer, no response. And what a ping is basically just a message that a computer sends called an ICMP echo request, and it sends a message to that computer in that specific destination, most likely using the IP address. And if that computer has connectivity and if the ICMP port is open, it should send a response. Now, if it doesn't get a response, it usually means there's no connection to that computer or destination. Next, the technician securely connects to the switch that is connected to the CEO's computer and displays the status information of all the ports in the switch. And if you don't know, a port is like it's just like a connection for the switch that allows each computer to go through and connect to other things. So for example, you can't just connect 3 computers to a switch if you don't know how many ports that switch has. If a switch only has 20 ports, for example, you can only connect up to 20 devices on that switch. Any more and you would either need another switch or a bridge or a repeater. And the status indication on the port indicates that it is down. So the technician types in the no shut command for that specific interface, and now the interface is brought up. So what happened? When the CEO changed their computer, there was a new MAC address that interfaced into the switch. And to go into what a MAC address is, it's kind of like an IP address. However, IP addresses can be changed very easy, but MAC addresses require a little bit more finesse. And a MAC address is like a unique hardware address that is burned into every single device. So like for example, every phone, every computer, every Apple Watch, every TV, every drone, anything that has independent connectivity with the internet or a network has its own MAC address. And the switch port that was connected to the CEO's computer had port security enabled, which remembers only one MAC address and shuts down when another address is connected. So the switch did not recognize the new computer's MAC address and reacted by automatically shutting down the network interface, causing the CEO's computer issues. Next is the networking upgrade. That is keeping operating systems, firmware, and software on all networking devices up to date. It replaces aging or obsolete components with better or more updated hardware. So like say for example you had a switch which only had a throughput of maybe 1 gigabit per second for each port, and there came a new switch that allowed 10 gigabits per second on each port. Part of what a network technician would do is configure and change up all the rules on that new switch to make it identical to the last one while keeping all the benefits of the improved technology. Cybersecurity and networking. Network technicians can also be in charge of making sure the network is secure and protected from attackers. VLANs, port security, static IP addressing scheme, authentication protocols, encryption protocols, physical access control, network access control, firewalls, and virtual private networks are all methods that technicians can use in order to further secure the computer network and prevent intrusion from hackers. The future of networking. With the rise of Internet of Things enabled devices, it is reasonable to speculate that an increase in network management becomes more important with increasingly complex networks. There's going to be an increased demand with all the new devices being added into the internet. So I think the utility of a network technician is only going to go up from here. So how does somebody who's interested in computer networking get started? I would say the first step is to try to earn an industry certification like CompTIA's Network Plus or Cisco's CCNA. Now, those are really hard tests to take that only somebody with really deep knowledge would be able to pass. And it also lets you know along the way if you're even capable of persevering enough to try to learn and be able to take that test, because it requires a lot of studying and knowledge, and you'll probably figure out beforehand if networking was something you enjoyed or not. Any questions? If there's no questions, then I will end the presentation. Thank you.